understand the flow over a wind foil or automobile or structure, and it's cheaper to test something in a wind tunnel than to build a full-size model and take it out and test it in the actual conditions. So that's why we do things in a wind tunnel. I think this is, again, 787 aircraft in a wind tunnel. This is a new 777 aircraft in a wind tunnel. I can't remember the scale for that aircraft. Again, because in a wind tunnel, because it's cheaper and easier to test the aircraft within that environment. And we'll try to do it full scale. NASA has wind tunnels. They do the same thing. Very large, 80-foot by 120-foot wind tunnel there over at Ames. That's testing up there. I think that's the Hornet, F-18 Hornet. And then they're doing the same thing on the right here. Langley, that we're saying is testing the wind foil wind tunnel. This one's a little bit more intricate because just like on an actual aircraft, as you can see, their airflow can change. We've seen aircraft have flaps. Another thing you might not notice they have on the front here, this changes the shape of the aircraft, so airflow. So like I said, depending on what they want the wing to do, they want to be able to just do level flight glide for long distance, or they want it to be maneuverable in terms of the shape of the wing. As you can see, this is a fighter. Wants to maneuver. Look at its airfoil. Pretty straight, different configuration than the 787 one, which longer, more surface areas. Different types of wind tunnels. Another reason why when we do wind tunnel testing, this is the cost of doing wind tunnel testing. NASA wind, $1,000 an hour. Some things they can test. Give the same answers for not just $2 an hour, so that's what you're trying to save some money when you're developing these kinds of aircraft. So, in our wind tunnel, this is what the interior looks like. It's built out of metal so the air can flow. Divided into two speeds, 10 and 15 miles an hour. This section, again, is this where you see this airfoil. That's where we put the model. This lifts up. We're going to mount the model inside. The spindle numbers is important as you take a look at it. It's a number that's used for calculations. For zero angle attack and certain airfoils like a constant. Last year we gave that to the teams. Your equation. I think I have the equations I'll show you. That was just something that we gave the teams for them to use and help them develop their designs. This is what our wind tunnel looks like. So the test space that you can see is in here. You might be able to see the bracket from this plexiglass lifts up and we mount the model inside. Turn it on. You can't see in these pictures, but we attach the wiring and interface to the brackets here. And on where to get data when we're doing the actual testing. Finding the basic problems for them is calculating the lift for two air speeds at 10, 15 miles an hour based on your design, and then using this equation and your data based on your design, calculate what the lift would be. Coefficient of lift is dependent upon the angle of attack. In our model here, the bracket keeps it at zero angle of attack. We didn't limit them if they wanted to figure out some way to mount it to change their angle of attack to give them a better lift. It was a little too much for us to fight off at the time, so we just decided to limit ourselves to that. Also, they have to calculate drag using the equations. The constant I was talking about is just our Reynolds number, and so that's they would plug into that equation when they did the calculations. And then then finally they tested the airfoil for lift and drag at the 2 airspeeds. And then finally, when they could compare their calculated values to their measured values. This is restate some of the things we've already talked about, how we're going to test. Just putting the airfoil within the wind tunnel, getting the specifics we already discussed. And then we recorded the lift and drag measurements for both speeds based on the data that we got off of the mountain. So, how do we then evaluate teams and determine the winner? So, these are the categories of grading that we've come up with. Lori and his team are coming up with a grading rubric. We have a graded panel last year. Use the grading rubric to calculate this. Also, the teams had to do a presentation of their project. Sure. For the middle school, you don't have to do that. If, like I said, if you wanted to try to see how your design would work in the wind tunnel, first thing you have to do is you guys can have a copy of this presentation, and you can see what the size of that bracket will be, and then depending on what you came up with, we can brainstorm some ideas of how we might want to attach that to the bracket. So if you wanted to do it unofficially, just to see what would happen, we can maybe set up some time after the informal competition and see what's going to happen. Just unless you want to enter it formally, I don't know if there's any reason, but you have to talk to Lori. So it's just a thought.
Yeah. We'll make it available for you guys to test in the wind tunnel if you would like, but we certainly will not make it a requirement. It's just going to be a little harder.
Benefit since you have this.
Since there is the cool wind tunnel, you can put your glider in it if you'd like. Just for fun afterwards.
Like I said, we haven't done any testing or done anything about using materials you would use, how it would survive 10 or 15 miles an hour. It's the only way I can. Like I said, stick it out your car window and see what happens. It stays together, it'll probably survive. So they were evaluating on these points: the efficiency, their specifications, aesthetics, and decide what we wanted. Something looks good. Accuracy of calculations, how close did their predicted values come to the actual values. And they did a presentation, tell us how they process they went through, lessons learned. And then try to explain if there were differences between what we calculated and what came out of the wind tunnel, just like any engineer. Why is it different? What factors cause the actual values of the airfield to be different than what we predicted? And so that we can learn from it. So that was another part of our exercise. And we make sure all team members should participate because we didn't want someone in the group to have the opportunity to stand up in front of a large crowd and talk. Get a learning experience. Not that we're trying to intimidate anybody or put them on the spot. We just thought it would be a good learning experience. So that was part of it. Right? All the team members had to participate. So that stage.